students, in this topic we will start with motion, chapter of motion. So what is motion? Usually we know that it's a movement like running, walking, skipping or moving from one place to another. So let's start with the lesson now. Next. So you might have seen somebody running. So you will observe that person running from one point to another point. So that relates to the movement of the particular person from one place to another. It is known as motion. So what does it tell here? It is the movement of any object. So it's movement of any object from one position. So if they start from one position, that is one point to another point, it's known as one position to another position. So with respect to the observer, as I told, as taking an example as we are the observer, as we see somebody else moving, we are the observer. As per our point of view, we can see a person moving from one place to another, or there is a change in position from one position to another. It is known as motion. So you can see here a little boy is running here. So next comes the motion along a straight line. So it's very easy to understand. Movement along a straight line is, take an example of a bike or a cycle or car, and you are going in a national highway. So what does it say? That the national highway road is in a straight line. There is no curves there. So if you are going in a straight line, it is known as the motion along a straight line. So here we can say that when an object moves along a straight line, the motion of object, so what is it called? The movement of that particular object is known as rectilinear motion. So as I told, example, the motion of a car on the highway. So next. So let's understand now the difference between vector and scalar quantities. So what is a vector quantity? We'll start with now. So you can see here, vector quantity is a quantity which has both magnitude and direction. So you can see here the weight of vector quantity, it has both magnitude and direction. So example is, you put a force, there is a magnitude, and the force that you have applied, opposite to that there will be the movement of the object. So with respect to the position, movement of position, there is also with respect to magnitude and direction. So next we will see about scalar quantity. So what is a scalar quantity? It is not associated with respect to the direction. So scalar is a quantity with which direction is not associated. Direction can be anything. So you can see with respect to mass. So speed is a scalar quantity. How it can be a scalar quantity? Because here you can see that speed can be varied. So another example is mass, temperature, time, etc., wherein the time also is not related to any direction, mass is not related to any direction, and you can see that speed also is not related to the direction of the car. So next, going to distance. So what is distance? So if you stand at a point A and you need to go to a point B, say it is 10 meters. So that distance, that is from point A to point B, it is known as the distance. So let's see here, the length of path covered by a moving object in a given time. So it is the path that is covered by a moving object. So we'll take the example of car again. So car has started from point A and it has started from A with the time as 10 a.m. Say a time as 10 a.m. and it traveled to some distance and reached B at 10:30 a.m. So that is the moving of an object in a given time irrespective of the directions. So irrespective of what direction it is known as the distance. So it is measured in a scalar quantity and its SI unit is meters. So here example, that is start. So this is the start point. So the travel, the movement of an object has taken place with end. So you can see that how much time the person has traveled and also the movement of the person from start to end is known as a distance. So next we will see about displacement. So as I told distance, so A to B is the distance. So here a person started and he moved along this path and reached this distance, but the shortest distance traveled, so the person could have even traveled from here to here, that is from A to B, and the shortest distance traveled is known as displacement. So let's see here, the shortest distance measured from initial to final position of an object is known as displacement. So this is known as, so it is used as a vector quantity. So the person here, you can see a boy, he wants to reach to the tree. So either he can go from here to the house, then to the tree. So if he is going from this A point tree to the house and then to the tree, it is distance traveled. But the shortest distance from A to C, that is this tree, is known as displacement. So next, so what is uniform motion? So you travel from one place to another at a proper, that is a speed of 10 km per hour at a regular interval. It is known as uniform motion. So when an object covers equal distances in equal intervals of time, it is said to be uniform motion. So let's take an example. A man drives a car from city A. So this is city A. He drives a car from city A and he travels to city B. So distance between city A and B is 90 kilometers. So if the man covers a distance of first 30 kilometers, say first 30 kilometers he has covered in 0.5 hours. So first 30 he has covered in 0.5 hours. The next 30 also he will cover in 0.5 hours. Then so on, it will be divided into a equal distance with respect to the time is known as uniform motion. So thus we can say that present motion of car was uniform throughout the journey. See here, first 30 kilometers, next 30 kilometers and the final 30 kilometers, all with respect to 0.5 hours of journey each. So next, coming to non-uniform motion. So as I told, non-uniform motion is like you start from A and at B, but in between you have an irregular intervals of time is known as non-uniform motion. So here when an object covers unequal distance, the distance is also not the same and the hours travelled also differs, is known as non-uniform motion. So when an object covers unequal distances in equal intervals of time, it is said to be non-uniform motion. So you can see here the meters. So 0 meter, 4 meter, 8 and 12. So here the meters, the distance travelled is same or regular intervals of time, but the distance travelled is the different. So it was here 0 to 4, 4 to 8, 8 to 12. So the distances are different here when the car started from point A until it reaches point B. So we have seen about the uniform and non-uniform motion now. Now we will speak about or know about the speed. Speed is represented by S. So what is speed? It is the distance travelled by an object in a unit time. It is referred to as speed. So let's see how it is represented. So acceleration equals to final velocity minus initial velocity by time. So it is acceleration is represented as A, final velocity is represented as V initial velocity by u and time t. So you can substitute here as a is equal to v minus u by t. So here you cross multiply here. So at is equal to v minus u. So what will be v then? So what is v here? V is the final velocity. So speed is with respect to the final velocity, acceleration, time and the initial velocity. So you can see what is final velocity? It is u plus at. So at has been brought over here and v is, or you can bring it here. So it will be v is equal to u plus at. So that is the mathematical expression with respect to the speed. And the SI unit of speed is meter per second. It can be represented by m by s. So it is also a scalar quantity. So that's all about this topic. We'll be continuing in the next video. Thanks for watching.